Alright, so here we have two separate logarithms, natural logarithms. We're going to go ahead and condense this to one. So one of the techniques you're going to usually do with when you have multiple logarithms is you need to condense it to a single logarithm and then do ELB. So that's what we're going to do right now. Remember, this 2 goes back up as an exponent. 5 squared would be 25. Addition means multiplication, so I get 25x. Recall that natural log is log base e. So if I do ELB, the exponent is the logarithm of the base. We divided both sides by 25. And this is the exact answer. If you were to put this in a calculator, you're going to get something along the order of 119.2. Now, of course, you could always check this by using your calculator. You could go ahead and put this back in. And theoretically, if you put this in a calculator, it should be extremely close to 8. You'll probably get 7.99 something because we rounded, okay? You're not required to check your answers. If you want to, it's definitely an option. This is already set for us as a single logarithm. So I'm going to go ahead and do ELB. So the exponent is the logarithm of the base. Of course, you could always plug that back in to see if it actually works out. However, this would be a little bit more difficult because it's log base 3. Excuse me. Your calculators may not do log base 3. So this might be a little bit more difficult to check. You could, of course, if you do a change of base. But, yeah. Okay. C. This is not a logarithm, but you'll notice that the variable is an exponent. We'll do ELB. So the exponent is the logarithm of the base. Log base e is natural logarithm. This is the exact answer. If we were to put in a calculator, it would come out to be something along 0.4. And of course, this one you could go ahead and check, right? You could plug in the 0.4 in for x and then see if it comes out to be 85. We have, once again, the case of multiple logarithms. So let's express this as a single logarithm. Keep in mind these parentheses are important because that's a package deal. Do not separate the package. However, these logarithms are being minused, and therefore we're going to subtract. If they're subtracting, we're going to divide, right? So they're going to divide these. It'll be x plus 1 up here, 2x minus 3 down here. This is the numerator. This is the denominator if we have a minus. Logarithms, subtraction is division. Because we have a single logarithm, now I can do ELB, right? 3 will be my base. My exponent will be 2. This 3 squared is a 9. I'm going to set this over 1, and I'm going to go ahead and cross multiply. We would distribute. We're going to move things around, so I'm going to move this x over here, and this minus 27 over here. We're solving for x, right? Combine like terms. That's the exact answer. We put in the calculator, we can get an approximation. Let's see, 1.65, something like that. Again, it's to be a little bit more difficult to check because the bases are not the same. Okay. We have a single logarithm, but let's be careful. There's a few things here that we need to be cognizant of. There is this power, right? And there is this missing base. The missing base is 10. It's a common logarithm. So if this is a common logarithm, we could do ELB. Let's do ELB. If we're going to solve for this x, I'm going to square root both sides. I know some of you are thinking, like, why don't you just do 10 to the 4th? I could, but I'm going to do extra work that I need to do. I'm going to square root. So if I square root, of course, I get this by itself. The square is gone. But if I square root of 4th power, I get a second power. So that's 10 squared. Now, if that hurts your brain, it's okay. You can do 10 to the 4th is, 1 followed by 4 zeros, right? You could do the math, then square root that number, and that number is going to come out to be 100 anyway. By this point in your mathematical learning, you're noticing that I'm doing algebra rather quickly because you need to be at a point where you can do algebra rather quickly. Okay, it should flow pretty smooth. I mean, you should stop to pause and make sure things are working out right. But just a footnote: as we send you off to college, as we send it off to university, you need to be a lot more fluid with your math. So let it flow. Let it flow. Because it needs to be. It needs to do so. All right. You could check this one, of course, because it's a base 10, and your calculators do base 10. What the heck is going on with f? It's an exponential, but it's a logarithm at the same time. Well, this is fascinating because I'm gonna have you recall, right, when we have a base is the same as the argument, it's the equal to the exponent. So I'm gonna do that. I'm gonna natural log both sides. I'm going to natural log both sides. And remember, natural log is log base e. And remember what we've said in the past. We've done this with the patterns assignment, and we've done it a few times in class, and we demonstrated in a previous video that if the base and the argument are the same, then the power is the evaluated form. So what I'm proposing to you is because this base and this argument are the same, that this entire thing, just this left side, boils down to the exponent. The exponent is natural log 5x. You might have to go back and replay that segment again, just in case. What we did is I took the natural logarithm of both sides. Okay? That was the most convenient thing because this is base e. If this was base 10, I would have done the common logarithm of both sides. If this was a 2, I would have done log base 2 of both sides. Okay, so I picked natural log because I want to get the same base as the argument. That allows me to do the trick that, remember, like if we had log base e squared, then the answer was 2. So here, log base e of e is going to be the exponent, which is natural log 5x. Now, this, of course, is log base e, 5x. I can do ELB, right? This is the base e. This is the exponent. But look again what happens. E to the natural log, right? This is going back to what we had before in the past. We can do the same process again, okay, and go through all this fanciness. The funny thing here is I divide both sides by 5. And if you were to put this in a calculator, you're going to get 7. If we do the same thing like we did before, this trick, right, with the log base EE, it would have come out to be 35 over 5, which is 7 anyway. I would propose to you, this is one you're going to want to check. If you haven't checked any of the other ones, you might want to pause the video and check. Plug in the 7 right here and look at the magic that happens. And you might want to take a moment to reflect in your left column about what happened with F. It was like the same thing happening over and over again. Okay? So it would be a good idea to pause and reflect on F. Finally, G. We'll go ahead and, because this is a nice decimal, I'm going to go ahead and actually make it as a decimal. There's no rounding right here. It was actually negative 2.25. Recall that this is base E. So much of what we do in solving these things requires you at some point to use ELB. So you have to be solid with ELB. You can't be pausing every time you do a problem, looking for Khan Academy or YouTube where it shows you how to do the arrows, right? If you can't do ELB and you're dependent on the arrows, you're gonna be confused all the time. Please take the moment to really be solid with ELB. The exponent is the logarithm of the base, because in this video alone, we have used it, I think, a dozen times. You have to be fluid with ELB. I'm about to do it right now, right? The exponent is usually by itself, is a number by itself. The base is right here. This is the argument. It's the leftovers. It goes at the other side. Okay? Subtract 1 from both sides. Divide by 8. That's a 2, by the way. So x equals e to the negative 2.25 minus 1 over 8, which if you put in a calculator comes out to be approximately negative 0.112, I want to say, after I round. And you could check this one, right? If it's a natural log or a common log, you can actually check them. You can plug them in and check out what happens there. Okay? Okay. For your summary, what are some techniques that you saw today, some themes that kept popping up that helped in solving logarithmic equations? So take some time to reflect on that.